Everyone. Thank you for coming to our presentation, and I'm very excited to be here today. My name is Dave-Inder Comar. I'm Executive Director of Just Atonement, Inc., and I'm a current PhD candidate in international law at the Grotius Center for International Legal Studies at Leiden University. I'm very pleased to welcome you to our side event, Climate Change, Tipping Points, and Human Rights. Our amazing panel is composed today of some of the top scientists in the world working on climate tipping points, as well as some of the top human rights experts on the issue of climate change. It is an honor for me to be sitting up here with these people. A few introductory remarks, and then I'll hand it over to our panel. Climate change is here, and our planet is radically changing. It is becoming hotter and less hospitable. As we will hear in just a few minutes, warming at and after 1.5 degrees threatens to trigger a variety of climate tipping points that will radically remake the physical geography of the Earth. The old Earth that many of us know is gone. Too many of us have taken the stable climate conditions of the Holocene for granted. The UN Charter was founded on the need for universal peace and the promotion and protection of the self-determination of all peoples. The right to self-determination was the foundation for decades of decolonization, in which colonized peoples invoked the principle to demand their freedom and sovereignty from imperial systems. The right to self-determination is a fundamental basis of our international legal order, and it calls for the end of apartheid and occupation, the promotion and preservation of culture and cultural rights, the right to development, and the permanent sovereignty over natural resources. It is closely related to sovereign equality and also informs the duty to cooperate. Climate change is transforming the physical conditions on which peoples depend for their survival. We know the Arctic is now warming 4 times faster than the rest of the planet, changing the lived realities of indigenous peoples and also non-human life. Sea level rise threatens to submerge the territories of small island states and low-lying states. Extreme heat may render parts of the world permanently uninhabitable. These are not distant hypotheticals, they are unfolding realities. As such, material threats to the right to self-determination do not come only from armies and occupations, but also from greenhouse gas emissions and inaction. We must look honestly and soberly at the conduct of high-emission states and ask whether their failure to stop emissions is consistent with the protection of the right to self-determination. As we will now hear from the esteemed panel, let us consider and reflect upon the climate conditions that we are rapidly losing. For example, how much polar ice will remain is up to us. Self-determination was the promise of the post-colonial order, that all peoples would be allowed to choose their destiny free and equal without domination. Climate change is breaking that promise, and tipping points threaten to shatter it beyond repair. An international legal movement as profound and as far-reaching as decolonization is now needed so that we can turn the ship around and return to a habitable planet. I don't know how hot the planet will get, but I do know that we will only survive by changing our perspectives to prioritize existence and survival, dignity and equal rights for all peoples, and prioritizing the maintenance of a habitable planet. I will now introduce our panel. Dr. Andrew Hartley is a senior scientist at the UK Met Office, Hartley Center, where he has worked since 2009, analyzing the risks of climate change to help governments, businesses, and NGOs adapt. His research covers the multi-sector impact of climate change, including biodiversity impacts, ecosystem resilience, and land cover change. He is a contributor to the EU-funded TipESM project, studying the societal and ecosystem consequences of climate change tipping points. He holds a PhD and has been cited over 2,300 times across his published work. Dr. Hartley, will you start, and then I'll introduce everyone before the presentations. Sure. Thank you very much.
Yeah. Thank you, Dave-Inder, and thank you everybody for coming today. It's really great to be here. Okay, so my name's Andy Hartley. I work in the Met Office Hartley Center, and I'm here today to talk to you about climate tipping points, what they are, and what could they mean for us, for the world's population. So firstly, I want to start with a look back at some recent events, okay? I think we can all start to resonate with some of these images. Climate change is happening now, okay? We all know this, and we all see this in the events that we are experiencing in our countries. So this is an example from the Valencia floods in October 2024, where at least 200 people were killed. And we know that climate change had a fingerprint in this event because we can do what's called climate attribution studies. So we can say, for example, that climate change made the heavy rainfall that led to this event 12% more intense. So we can start to build up a picture of the fingerprint of climate change in events like the Valencia floods. So we know climate change is also affecting wildfires. In a recent report that I was involved in looking at the global wildfires in 2024-25, we can find that let's say in South America, wildfire-related air pollution was 13 to 60 times above WHO standards in Brazil and Bolivia. Imagine that, 13 to 60 times above the recommended levels of air pollution. That's just from the smoke from fire. We know also, of course, the impact of fire on our communities. And you can see that in the Los Angeles wildfires in January 2025, where we know that fire weather was 6% more intense and 35% more likely because of human-induced climate change. And, you know, we looking at this at the event alone, 400 plus excess deaths were attributed to smoke exposure alone, let alone the direct impacts of fire. And the Los Angeles wildfires were also one of the most expensive and costly in history, with $140 billion in total damages. So we can see that climate change is having a big impact in flooding and in wildfires, and also in terms of other impacts of heavy rainfall, such as landslides in Brazil. So this is something that I've also been working on in the past, looking at the fingerprint of climate change in landslide events in Brazil. So in March 2020 in Baixada Santista in Brazil, on the southeast coast, there was 20 to 42% of total losses and damages were due to anthropogenic climate change. And we found that the long-term rains were 74% more likely, and the short-term trigger, the heavy rainfall that led to the event, 46% more likely because of human-induced climate change. So we can see that climate change is having a big impact now on the events that we're experiencing. Okay, next slide. So I'm here to talk about tipping points, and I think the first thing to do is to explain what a tipping point is to you. So firstly, a tipping point is an irreversible change in the Earth system, okay? And you can think of it like the Jenga video. I don't know how many of you in your countries know what Jenga is, but basically it's a game where you have a tower and you pull out the blocks, as you see in the video, and put the block at the top of the tower. And the tower stays as a tower for quite a long time until it falls over. And in that case, the blocks are still there, but it's in a different stable state. So, and what you might notice from the video when it gets there is that there's a wobble before the tower collapses. So you can see there's an early warning sign that the tipping point is about to occur. And so they're all factors, things that you can see in our climate system as well. And what we're trying to warn against here today is that what might happen if we enter this new stable state in different parts of the Earth system. Okay. So next slide, please. So where are some of the tipping points that could occur in the world? I want to pick out three from this diagram. So this diagram is courtesy of the Carbon Brief, which has an excellent communication on tipping points if you want to find out more information. But I want to focus on the Amazon rainforest to start off. So we know, I'm sure we all know that the Amazon rainforest is the lungs of the Earth, okay? It sequesters a lot of carbon. So some of the carbon, so roughly 25% of the CO2 that we emit is absorbed by the land. The biggest part of that is the Amazon rainforest. So the Amazon helps us to reduce some of the impacts of climate change. If the Amazon rainforest were to die back, then it would reduce its function, and accelerate climate change, which would have an impact on the global climate. But it would also, of course, have an impact on the people in Brazil and South America who depend on the moisture recycling from the forest. Okay, so this is one of the impacts, and Desi will talk next about a little bit more detail about the Amazon rainforest. So the second tipping point I want to bring up to you is the AMOC, so the Atlantic Meridional Overturning Circulation, and you can see this is in the middle of the North Atlantic. And basically the AMOC is the mechanism which brings heat from the tropics to the poles, and it keeps Northern Europe warm, and much warmer than similar latitudes in Canada and Russia. And the evidence is that the AMOC is starting to slow. Okay, so it's a long process, but there's the potential that this overturning circulation can slow to the point that it stops or reaches a new stable state, which is very, very low. And if that were to happen, that would bring colder temperatures to Northern Europe and significant reductions in rainfall. And I'm sure you can all imagine what impacts that might have, with effects on agriculture, effects on thermal comfort, etc., on infrastructure. And the final tipping point I want to highlight to you is the Greenland ice sheet right at the top there. We know that the Greenland, the ice stored in the Greenland ice sheet could lead, if it were all to melt, could lead up to 7 meters of sea level rise across the world. Okay, and so this is something we want to monitor and understand the sensitivity to climate change of the ice sheet. But this is something that you need to be aware of, especially the small island states here, is a particularly concerning potential tipping point. Okay, so I can imagine you might have a question of how certain are we of these tipping points, and at what point might they occur? And I suppose the easy answer for me as a scientist is to say there's ongoing research, but there's always uncertainty. And I'm sure the interactions you've had in the past with climate scientists has been around understanding uncertainty and how you act, even though you have uncertainty. Okay, but I want to show here an adaptation of a figure that was published a few years ago by some colleagues from Exeter University. And this looked at the kind of the range at which we might consider different tipping elements of the Earth system occurring. So if you look at the top scale here, you have a global warming level, which goes from 1, 2, 3, 4 degrees all the way up to 10 degrees global warming. Okay, so this isn't saying how likely those warming levels are, but if we were to have, say, 3 degrees warming, we might expect Greenland ice sheet to be a tipping point that we would be more confident that would happen. So you can also see it on the bottom of the diagram. The lines represent our current policies. So you can see 1.5 to 2 degrees is the range in the Paris the Paris Agreement commitments. If we were to follow net zero policies, we would roughly be at reaching 2 degrees global warming. But the current policies and our current trajectory is more towards 2.6, 2.7, 2.8 degrees global warming. And if we take that line of current policies, we can see that we're relatively confident of the Greenland ice sheet being vulnerable, but we can also not discount impacts in the Amazon rainforest and to the AMOC, to the Atlantic overturning circulation. And I'm happy to talk in a little bit more detail later about these sensitivities. Okay, next slide, please. So the final slide really here is the takeaway messages that I want you to remember from this presentation. Firstly, climate extremes are getting worse. They're happening now, and we can attribute them to climate change. But the important thing in our current situation is that we know that if we reduce greenhouse gas emissions, we can reduce the impact and the likelihood of these extreme events. Okay, so that's the world that we live in now. But if we get close to these tipping points, these irreversible tipping points, we will not be in a situation where we can go back, because these tipping points will occur and we won't be able to go back to our current state by just cutting emissions. Okay, so this is why we're here today, because we want to convey to you the seriousness of the tipping points. And that's my final message, really. So thank you for your attention.
Thank you, Dr. Hartley. And there'll be time at the end for questions. I'd like to give the floor now to Dr. Desislava Petrova. And Dr. Petrova is co-chair of the Climate and Planetary Change Hub at the Barcelona Institute for Global Health, where her research focuses on climate dynamics, predictability, and change. She holds a PhD in climate dynamics from the University of Barcelona and is a leading expert on El Nino prediction, having developed a novel model capable of forecasting ENSO events up to 2.5 years in advance. She also contributes to the TipESM project and works on how climate forecasts can be integrated into health impact models, and she focuses on the impacts of El Nino Southern Oscillation on the Amazon rainforest and the implications for its tipping. Dr. Petrova, it's a pleasure to be here with you. Please go ahead.
Thank you. It's also a pleasure for me to be here. My name is Desislava Petrova, and I'm a climate scientist at the Climate and Health Group of the Barcelona Institute for Global Health, as it was already introduced. And my talk today is on the potential tipping point of the Amazon rainforest. So the Amazon is a major biodiversity hotspot containing 10% of the Earth species, many of which are endemic to the region. It is also a critical element of the climate system because of its impact on the water cycle and on the carbon cycle. It contributes 15% of the world's river discharge, total river discharge into the ocean, and adds huge amount of water to the atmosphere in the form of evapotranspiration, thus forming rain clouds. And it is important to say that the Amazon rainforest has been an important carbon dioxide sink for millions of years. So next slide. However, climate change in combination with anthropogenic land use, such as mineral and timber extraction and soil erosion, as well as water use, such as damming and fragmenting rivers and releasing huge amounts of sedimentation, has led to a substantial degradation of the Amazon rainforest in the recent decades. And so much so as that is now considered that about 38% of the rainforest is degraded. This schematic figure shows the main drivers of degradation in the Amazon rainforest. And in panel A, you can see that the main areas that were impacted by droughts since the early 2000s are the central lush part of the Amazon rainforest and also parts of the southern Amazon. In panel B, it can be observed in green that the areas that were most damaged by fires are the southern and eastern part of the Amazon. Then logging occurs everywhere, as you can see in the yellow color in panel C. But again, the most affected areas are the southern and eastern Amazon. And it's similar to edge effects, which refer to the physical and biological changes that happen at the boundary between cleared land and standing forest, because there is a transition area where it's hotter and drier, and it's more vulnerable to changes. So climate change in combination with anthropogenic use and this degradation could lead to the partial or complete dieback of the Amazon, which would be a critical transition from the state of having a lush tropical forest into having a savanna, which would be most probably reversible on human timescales. So climate model simulations have indicated that this transition could happen in a wide range of temperatures between 2 and 6 degrees of global warming with respect to pre-industrial levels, with the most likely range being between 3 and 4 degrees. But with additional deforestation that would exceed 20 to 25%, the Amazon rainforest becomes more susceptible to climate change. And this transition could actually happen at the lower levels of change at 2 to 2.5 degrees. So such a collapse of the Amazon rainforest would, of course, have catastrophic consequences. And this would be not only for the 40+ million people living in the Amazon, but for humanity as a whole, due to its impact. So there will be major food and water insecurity as a result of the impact on the water cycle, and potential deficits in major agricultural regions, such as the southern part of South America, for example. It would also lead to major biodiversity losses and the extinction of species, endemic species, and to the spread of infectious diseases and the propagation of viruses. Also, the transition of the Amazon from being a carbon dioxide sink into being a carbon dioxide source would actually inevitably lead to worsening global warming and the climate crisis. And all these consequences are expected to drive mass migrations and widespread political instabilities. So the most advanced Earth system models that feature dynamic vegetation and interactive forest fires have indicated that partial dieback of the Amazon could occur by the end of the century, under the assumption that CO2 increases by 1% per year since pre-industrial times. As you can see, these partial diebacks in red in these figures for the different models. But as you can also see, the models do not agree on the exact locations of these partial diebacks at this point. So this implies that we do need to run more experiments and better designed experiments. So in the TipESM project, we are interested to gain comprehensive understanding of climate tipping points, including the Amazon rainforest. And we do this by using, as I said, the most advanced Earth system models and by running targeted experiments. And we also focus on major climatic patterns, such as the El Niño Southern Oscillation and its potential impact on the Amazon in terms of causing droughts and forest fires and post-like destabilization. And the expected outcomes from the TipESM project are early warning indicators and safe emissions pathways to avoid the tipping of the Amazon, and also of other key elements of the climate system. So thank you.
Thank you very much. Thank you very much, Dr. Petrova. I'll now introduce our third speaker, Dr. Ivana Cvijanovic. Dr. Cvijanovic is a climate scientist at the French National Research Institute for Sustainable Development with expertise in atmospheric teleconnections, heat waves, future rainfall changes, and climate impacts on human health. She's a contributor to the TipESM project on tipping points in Earth system models funded by the European Union. Her recent research has examined how Arctic sea ice loss drives regional climate changes and how rising heat stress affects human mortality and threatens outdoor sporting events across Europe. Dr. Cvijanovic, you have the floor.
Thank you. Will you be changing slides for me? Yes. Okay. Thank you very much, Dave. So for this final scientific presentation of our session, I'm going to try to start with a question of, do we need a legal framework for loss of habitability due to extreme heat? I will try to present my argument to you today, and then I'm looking very much forward to hearing your perspective and have further discussions on the topic. Now, the issue of habitability has been quite widely recognized in the context of sea level rise. Here we see a picture of Tuvalu Foreign Minister Simon Coffey delivering his COP26 address while symbolically standing in the ocean. And luckily for luckily, for low-lying islands such as Tuvalu, the international response was not on the level of sending snorkeling equipment, but it was widely recognized that humans should not live in the water or under the water, and some national relocation plans have been put in place. And well, from a human rights perspective, these plans could benefit from some major improvements, at least from a viewpoint of providing like a survival of lifeline. These agreements exist. And this is not something we can say is the case for some other life-threatening climate hazards. And one of them that I would like to bring your attention today to is the extreme heat. So extreme heat is already killing lots of people around the world. And in fact, it is considered one of the leading causes of climate change-induced mortality worldwide. The issue is that we have extremely unbalanced monitoring of impacts of extreme heat between global north and global south. So we know very well what's happening in North America, in Europe. We have these reports like the statement from World Health Organization that heat claims more than 175,000 lives annually in Europe. And then from the global south, where we have really major heat waves, we have reports on something like tens or hundreds of deaths, which doesn't really make sense. So because we have record-breaking heat waves happening there like we had never seen before. So here is an example from last spring. We have this record-breaking heat wave in West Africa and Sahel that pretty much takes over half of the continent. Here we see that, the half of the continent has temperature anomaly that is 10 degrees above the average. This is a snapshot from April 1st, 2024. But then again, when it comes to climate impacts, we know very little. And I want to put this in a perspective with something that we know. So Paris heat wave 2003 was very much followed in the media. We know that there were about close to 1,000 excess deaths in Paris reported and about 15,000 deaths across France. And what you see here in this panel is a measure of heat stress. It is called wet bulb globe temperature, or WBGT. And here you see hourly values of WBGT for every day in August of 2003. Now, when WBGT crosses this red line of 30, the conditions are considered very, very dangerous. And if it would cross 33, they would be considered extremely dangerous. So at least in this data set, originating from reanalysis data, Paris never crossed WBGT of 30 and had 1,000 excess deaths reported. And now I want to contrast this with a heat wave in Western Africa. Here is Niamey, May 2010 in purple. Every single day in May, WBGT was above 30. 13 days in May, the WBGT was above 33. Again, that is extremely dangerous. And at some points, that happened for 4 consecutive hours. So everything we know about WBGT theoretically would indicate that this was really huge mass mortality event. And we don't know what was the excess mortality of this event. And this is a really big problem for us scientifically. Now, other big problem for us is the future and rising global temperatures. So there was a recent study that used laboratory-derived human survivability thresholds and applied them to climate simulations. And they concluded that at 3 degrees global warming, approximately 1.7 billion people would be exposed at least 1 week per year of deadly heat stress conditions. You can see the regions: Western Africa, Indian subcontinent, Southeast Asia, Arabian Peninsula. Scientists do not necessarily agree that the threshold applied in this study is the best one. So there is lots of scientific debate currently of what survivability thresholds we should be using. So let's assume 1.7 billion was an overestimate, but would it be much easier if it was 1 billion or 500 million? Can we act on 500 million either? I mean, these are incredibly high numbers in any case. So this issue of threshold is actually something that your community and our scientific community are going to have to talk about. And this is because how we react to heat depends on our personal characteristics. So depends on our age, on our fitness, whether we have chronic conditions, whether we have to perform work when it's really hot, do we have access to hydration or to air conditioning? And yeah, obviously many people around the world don't have access to air conditioning and will be exposed to extreme heat for many consecutive hours. So we will eventually, as scientific community, need recommendations from legal communities like yours regarding the vulnerability categories on which these survivability estimates should be based. And that will be really important for us. But yeah, to go back to the sea level rise versus extreme heat comparison that I kind of started this presentation with, you know, like when it comes to sea level rise, we have in a way acknowledged that one's right to life has been endangered. But when it comes to heat, we have not quite done so. So if our desired target for sea level rise would be no human expected to live underwater, then the parallel target for extreme heat should be no human expected to live exposed to deadly heat stress conditions. And climate model projections indicated that that target will be surpassed. Okay, so climate model projections indicate some areas will inevitably be under the sea. They may disagree about when and how much, but some areas will be under the sea. And similarly, climate models predict certain areas will face deadly heat stress levels. Depending on the threshold we apply, maybe a larger or smaller area, but they will exceed deadly heat stress levels. Now, the time to act, like in a case of sea level rise, is not when someone is under the water. It is when current conditions are already affecting life's quality. So we see consequences from storm surges, we see saline water intrusion into drinking water resources. This is the time we should plan action. At the same time, with extreme heat, right now, we have severe heat stress causing increased mortality and health burden, livestock loss, agricultural losses, but we don't have similar concrete actions. And in terms of actions in place, yeah, so sea level rise here comes as a positive example, although clearly there is much more to do on that side. But on a sea level rise, we do have efforts to strengthen storm surge defense systems. We have some sort of relocations planned. Versus on extreme heat side, we have relatively slow development of these heat health warning systems. We have some temporary makeshift solutions like this one. That's very good, but that will not help when we have several hours of life-threatening heat. So the choice is, to me, kind of obvious, but I'll present it to you. At 1.5 degrees global warming, we can still speak about heat adaptation. Here we can speak about these heat health warning systems. We can adjust urban areas. We can take some measures to protect livestock and agriculture. At 2 degrees global warming, heat adaptation becomes really difficult and very costly. We're starting to lose lots of lives. At 3 degrees, there's so many people affected that there is nothing we can do. We're crossing the adaptation limit to heat. So yeah, the choice does seem obvious from my perspective, but I want to remind you that our current pledges as a society are leading us on average to 2.6 degrees global warming. So this is the world between yellow and red one. Thank you.
Thank you very much, Dr. Cvijanovic. And now I'm going to change, the presentation will change slightly from the science to human rights issues more specifically. And I'm quite thrilled and honored to introduce our next speakers. Professor Elisa Morgera, the Special Rapporteur on Climate Change and Human Rights, needs no introduction, but she was appointed Special Rapporteur in 2024, selected from over 50 candidates. She's also currently Professor of International Law and Sustainability at Durham University and Professor in International and European Union Environmental Law at the University of Eastern Finland. Professor Morgera, will you speak? Yeah, thank you very much.
Yeah, thank you so much. It's been an incredible experience, learning experience to be on this panel. And indeed, it is our hope that this will be one of many conversations we'll keep having with the scientific community working on tipping points. I just want to share a few reflections about how, while scientists work towards advancing our methods for understanding, for predicting, for giving information that can save lives in the context of climate change, and they have their own standards of certainty. From a legal perspective, we have different standards, and we can already understand state obligations, business responsibility, the responsibilities of funding institutions, of researchers themselves on the basis of international law. And to me, there's a few aspects already from what we've learned today that really clarify how tipping point science, for how much it is an area of science that's been developing, it's clearly linked to some of the key legal clarifications offered by the International Court of Justice in its advisory opinion on state obligations on climate change. And of course, one of the key overarching findings of the court is that all states have to do their utmost as a matter of obligation, undertake their highest possible ambition to prevent significant harm to the environment and to the climate system. And so even if we might not be yet at a point of scientific certainty around when we might cross and lead to irreversible harm, it seems to me that we have significant scientific evidence that we're heading towards potentially irreversible harm, and there were certainly many areas of the tipping points, in fact, maybe all of them, causing significant harm. And critically, the International Court of Justice reminded states that their obligations to prevent significant harm are obligation of stringent due diligence. They're based on the precautionary and the ecosystem approach. And so another key aspect of tipping point science, which I think we as an international human rights community ponder, is also how each tipping point is connected to the other. And while we have, for instance, now preparation of a new report for the Human Rights Council on sea level rise, we need to understand how changes and progress in the harm that's leading us to a potential tipping point is linked to other areas of research and understanding of changes across different regions. And for me, that also has a really important aspect of solidarity and understanding of the science in terms of duty of international cooperation. We might be privileged enough to live in a country, in a region, in a locality that has not yet suffered extreme climate events, who might not be facing some of the very much verifiable and monitored impacts of some of the tipping point science is showing us. But all our destinies are dependent from what is happening across those tipping points. What is happening in the Amazon, what is happening with the ice caps matters for all of us right now, for our possibilities not only of a livable existence, but a dignified, livable existence, our access to water, to food, to conditions that can allow us to socialize, to go to work, with our families, are all at stake. And they matter no matter where they're occurring across the planet, which in a way challenges perhaps the usual human rights framing of responsibilities domestically and extraterritorial responsibilities. We are all interconnected, and the protection of our human rights is interconnected with the protection of the environment in all of its elements across the world. What this also means is that what are the priorities for science and what are the obligations of states right now at the current level of development of tipping point science? I very much agree with what was shared about how important the work of scientists is to help us develop early warning systems. And we've heard how much and how hard colleagues are working towards that. And of course, within that, we have so many insights and, in fact, scientific evidence arising from human rights work for engagement with individuals, communities who are bearing the brunt of climate change, and already give us significant indication for the question that, for instance, Ivana posed around what are the categories of vulnerability. We have several UN Special Rapporteurs and other experts who, in their dialogue with most affected individuals, groups, and peoples, have seen and documented how basically we have seen intersectional harm arising from climate change. And we have also legal documents clarifying state obligations in relation to specific and, again, stringent due diligence measures to ensure adequate and proportionate protection for children, for women at different ages, for persons with disabilities, for indigenous peoples, for peasants and small-scale fishers whose lives, well-being, cultures, ways of life are more intimately connected with nature than maybe some other parts of society. And I think, to me, there's an element which I have stressed in my second report about access to information to the public. The public needs to understand that we have sufficient evidence of how multiple irreversible points there are at the horizon. And even if we might not exactly know when that horizon might be, that's already a crucial consideration in any public decision-making space. Understanding how significant, how urgent, how essential to everyone's well-being, to the dignified livability of our conditions, to understand that our decisions today can prevent the verifying of tipping points. And that also leads, I think, to the point around monitoring. What are the obligations of monitoring, and also the obligations of states of prioritizing funding for research that can support the effective protection of human rights in the context, in particular, of tipping points and climate change more generally. And while it is really important to monitor the deaths, for instance, from extreme heat, and I've had several conversations in the global north and in the global south where we know that extreme heat deaths are underreported by employers, by public authorities, by the medical profession for a series of reasons. But the point is that extreme heat is also causing many other severe harm to human rights, harm to health, physical and mental, which itself has then knock-on effects on other human rights and on our economies. Has impacts in terms of health costs. It has impacts in terms of access to education. And last year we had an alarm bell around how the climate crisis is also an education crisis. 1 in 7 children experienced severe disruption of their education because of climate change in 2024. So we have several, I think, elements of monitoring the impacts of the areas of climate impacts that are covered by tipping point science that have very specific and measurable impacts on all our human rights. And we do need to monitor those impacts on all the relevant human rights from an intersectionality perspective to make sure that states have all the information they need to develop those specific, targeted, proportionate measures to protect human rights holders for what are foreseeable negative impacts on the whole range of their human rights. And maybe the last point I want to share is that at the moment I'm working on my next report to the Human Rights Council that's focused on food systems, climate change and human rights. And I'm really interested in understanding how not only what we know already from tipping point science that can help us understand, again, priority action for states in protecting our food systems from the negative impacts of climate change, in transforming our food systems so that they contribute much, much less to climate change and in fact contribute to an economy-wide transformation away from a fossil fuel-based economy. But crucially, how we also show which other area of science, including health science, indigenous sciences, local knowledge, we need to bring together to show that maybe what are gaps at the moment in tipping science can be complemented by other areas of knowledge production that give us already a much finer grained sense of who's being most affected, how much is preventable, and what action we need to prioritize for effectively preventing significant, if not irreparable, climate harm and foreseeable, significant, and in many countries and regions, compounding human rights harm. Thank you.
Thank you very much, Professor Morgera. I'll now introduce Benjamin Schachter from the Office of UN High Commissioner for Human Rights. Benjamin Schachter is a human rights officer and environment and climate change team leader. Prior to joining OHCHR, he worked as an attorney in the United States as a research assistant to the UN Special Rapporteur on the rights of indigenous peoples. Mr. Schachter, please.
Thank you very much. Tough acts to follow, and not a lot of time left. So a couple of things I want to do, maybe build a bit on that human rights picture, but also I want to share a sort of metaphor, a way of thinking about this, because I think part of the challenge we have in the sort of science policy space is just understanding, you know, what does this really mean? And I would think about it like, let's say you drink a lot and you go to your doctor, and the doctor tells you, you keep going at this rate, you're going to have cirrhosis, an increased risk of dementia, you're going to have high blood pressure and likelihood of heart attack. And if any of those things happen to you, you're probably going to die, or your quality of life, your future of life will be irreversibly altered. Now, if you're a rational actor, you're going to slow down, right? If you're addicted, if you can't stop, you're going to keep right on going. And I feel like we're addicted to fossil fuel. And those things, the overturning, the tipping points we're talking about, you know, the Atlantic meridional overturning current, those are the organs of our planet, right? The Amazon rainforest. We always talk about the lungs, right? If we irreversibly damage those things, we're either headed towards life support for the planet or a completely different state of being, like the Jenga illustration we heard earlier. And people just don't seem to get it because we keep right on going down the same path. We're not reducing emissions. And here's where human rights, I think, they offer us a decision-making framework to transform science into better policy. And let me first start by saying we all have the human right to benefit from scientific progress and its applications. If that doesn't mean we should all be, and governments should all be ensuring that decisions are made based on evidence in order to prevent substantial harm to the environment and long-term impacts on people's rights now and in the future, it means absolutely nothing. So we all have the right to benefit from scientific progress and its applications. We all have the right to benefit from access to information. We all have the right to meaningful and informed participation. And this cluster of rights is what can transform science into informed and logical decision-making processes that will stop us from passing these tipping points and stop us from hopefully doing irreversible damage. Now, some of the science might be pointing to the fact we've already gone there in some cases, but you know, to the extent that we can still alter our behavior and change our trajectories, the way to do that is to ensure that decision-making processes are informed by human rights. And the other piece of this I'll say is that we have a real challenge with transparency and science, and with ensuring the safety and security of independent scientists. So not only do human rights need to inform how we apply and understand and act on information, human rights are essential to ensuring that we actually have good information in the first place, to protecting science and scientists. I could go in a lot longer. I think the other two quick things I want to say, right? It's about prevention. We need to make sure that we take action to prevent things, particularly you think about the precautionary principle in environmental law, where the risks are very high, the efforts to prevent should be higher still. And the risks here are catastrophic, yet the efforts to prevent are limited. We're very reactionary. We're willing to throw money at, you know, a humanitarian disaster, but we're seemingly really struggling to put money towards problems, stopping them before they manifest, even though that's a much more effective. And so again, going to science and going to the data, we know that prevention pays off. It's a better long-term economic decision. We know from the IPCC, science, again, human rights-based approaches to climate action lead to more effective and sustainable actions. So we have to figure out a way to break this addiction we have to bad decision-making, to a fossil fuel economy that's sending us off a cliff. And I'll stop there. Thank you.